Hello everyone, apologies in advance. I'm going to fly through the first part of this video. There is a note sheet that goes along with this. You might want to have that. Definitely helps me go faster. The beginning is some pretty simple polynomial vocabulary, and the ending will be the main topic in behavior. So you already know what constants mean from our synthetic division, but also make sure you understand that the constant is also the y-intercept when we graph it. Coefficients are numbers that are attached to the front of variables multiplied to the front. They can be negative, like -6, or they can be like quote unquote invisible and be 1, or even -1. Terms, a little grouping separated by pluses and minuses, grouping of coefficients and variables. It could be two variables, that's still one term right there, but when they're separated by plus or minus, that's different terms. Generally in math, we write things in descending order. So we got a third power, second power, first power, and no x's on that one. The leading term up here is 5x to the third because it's the one with the highest exponent. That's how it's supposed to be written when it's written in descending order. So it's written correctly, but the next one's not going to be written correctly. The leading coefficient is the 5. The constant up there is -6. Remember, that would also be the y-intercept if we graphed it. The degree is, most basic definition, highest exponent. A little bit more to it, you'll see coming up soon. Different names, like 3 terms is a trinomial. 3 or more can be called a polynomial. Poly means many. When you have a first degree, very important from math 1 and 2, when you have a first degree statement like a y equals 8x plus 5, that's x to the first power, it's always a line. But when you have a quadratic statement like a y equals 8x to the second plus 5, that would be a parabola. Could also be reflected across this horizontal if it would have been a negative 8x squared. Cubic is when we have some kind of x to the third power, which you'll start seeing in this video. X to the third power would look something like this. Quartic is fourth power, quintic is fifth power. Don't use those terms a whole lot. So a few random questions, put it in descending order. It's already in descending order, fourth power, third. You wouldn't need placeholders or anything to answer questions about. The leading term is 5x to the fourth. The coefficient on that leading term is 5. There's 5 terms up there, 1, 2, 3, 4, 5. Apologies for all the 5 answers. You can call this a polynomial, or you would call it quartic because it's fourth power. As you saw here, fourth degree, fourth power, quartic. The constant is -9. And remember, as far as right now, the highest exponent is the way we define degree. It's fourth degree. Next example, just a few more like now. This one is out of order, and if I wrote it in order, the highest exponent would be in the front, and that would mean the x to the 6th power one. Negative x to the 6th power, is in front. There are still 5 terms here. Highest exponent is 6. We don't have a name on here for 6th degree. We can still call it a polynomial because it's many terms. Leading term, the term in the front again, is negative x to the 6. That negative belongs to that x squared. The leading coefficient on there is -1. And finally, again, the constant is -6, which would also be the y-intercept again. Couple great little questions to ask about these. Again, I got to kind of rush through the first part of this video. Which line has only a constant on it? That would be I down here with the 9. Which two lines are first degree? So this one is second degree. We got a lot of exponents here. That's not first degree. More on that in a second. Oh, we got a first degree one right here on E, and another first degree one right here on H. So E and H. I know you might have some questions about why some of those look like first, and you'll see that some of those answers start here. Degree of line G. Well, degree of line G, nothing special here. The highest exponent is 4. So that's going to come up soon, what I was talking about. Which two lines have a y-intercept or a constant of 4? So you want a constant of 4. This one and E. E and J. Line B has how many terms? Got one here and one here. 2 terms. Let's say binomial. Which line has 3 terms? That would be J. Okay, so finally, more on this degree. The degree of line C. So I told you earlier, highest exponent. Some of y'all are probably thinking 5. But I told you there's a little bit more to the definition. When it's all one term, you're going to add up your exponents. So line C would be 5 plus 4 plus 2. The degree is 11 on this one. The degree of line B, again, is just 2, highest exponent. I didn't add those together because they're separate terms. Degree of line F, though, can be quite tricky. Pause it, think about the degree, see if you get it right. Well, hopefully, you said 8. Now, you might have said 7, and the reason why some kids will say 7, you see the 5 and the 2, but there's also a 1 for this y to the first power right here. So that's why the degree of line F would be 8. Which line is cubic? So cubic, remember, is 3rd power or 3rd degree, but this one's 4th, so be careful. We don't want that one. We want A. Leading term on line G. So remember, the highest exponent has to be the one in the front. So that one, G, is written out of order again. So the leading term is the whole -9 to the 4th. The leading coefficient is the -9. And finally, what's the constant on line A? If you look over here, a constant would be something like a +7 with no exponent or nothing, but it don't got nothing. The y-intercept or the constant is 0 on that one. So anyways, on some more like Math 3 related topics, and this is where we really start talking about this phrase called end behavior and how a function behaves on its ends, left side and right side. We say that a function is even degree when both ends are going in the same direction. So both ends on my current one are going up, but it could also be both ends going down. We say a function is odd degree when one end is going down and the other end is going up. So for discussion on the rest of this, I'm going to label this A, B, C, and D. So next up is, what is a positive function? Well, it's a positive, like most kids would look at A and say, yep, that's positive, and it is, and B is negative, and it is a negative function. When you look at C and D, it's a little harder to tell. So what you're going to do is you're just going to read the right side. If the right side is going up, it's positive. So C is a positive function. And D, the right side is going down. So D is a negative function. Now you would get that. You could get that from the degrees, as you'll see in a minute. From the leading term, I should say. Anytime we touch the x-axis, it's called a 0. That's going to be really important on the next lesson. A local min, max, and an extreme. I'm going to break down as I actually go through some pictures of these. So at the moment, this one is not on your note sheet. This is a good sample from what delta is going to look like. The degree is either positive or negative. Remember, they're going in opposite directions. So, wait. Positive, negative is going to go over here. I'm sorry. The degree is either odd or even. And they're going in opposite directions, so this one is odd. The leading coefficient is either going to be positive or negative. Remember, you read the right side, it's going up, so it's positive. There are blank, distinct real zeros. Anytime we touch the x-axis, intercept the x-axis, that's the 0 dust. So there's 5 of them in this case. Relative maximums, I said I'd explain it on a picture. Wherever we have a local high point, like here, there's a high point in here, there's a high point in here, but there's no max over here. It's going to go up forever over here. So there are 3 relative maximums. Don't panic, we'll do another one just like it. The degree is odd or even. Well, this time they're both going down, so it's even. The leading coefficient is positive or negative. Well, remember, you read the right side, and it's going down, so it is negative. There are blank, distinct real zeros. 1, 2, 3, 4, 5, 6. 6 real zeros, and this time they're asking for extremes. So that means they want highs and lows. They want mins plus the maxes. So we got 3 local maxes and 2 local mins for a total of 5 extremes. Make a real good time, so sorry I was in a rush, but definitely a good screen to talk about out of everything that I have to explain on the course of a year. I'll probably end up explaining this the most, but all you really need to understand about all these is sometimes we're talking about left, sometimes we're talking about right, and sometimes we're talking about up, and sometimes we're talking about down. And left and right is always some kind of X, and up and down is always some kind of Y. And we're not talking about necessarily graphing at this point, but left would be as X is approaching negative infinity, like a number line. As we go to the left, we're going to negative infinity. And as we go to the right, we're going to or approaching positive infinity. Meanwhile, up and down, Y is approaching for up positive infinity, and for down, Y is approaching negative infinity. So it's really just putting up, down, left, and right into math symbols. So anyways, to the question, in this picture, my left side, as X approaches negative infinity, that's left, my right side is going, oops, not talking about the right side yet until we get over here. My left side is going up, so my Y is going to infinity. So immediately, I like this answer, but I also like D. I'm sorry, that's a little bit off screen because X is approaching negative infinity. As X approaches negative infinity, my Y, aka f of X, is approaching infinity. A lot of use of the word infinity. Let me see if I can break that down a little better here. On the right side, so think about it as I would say the right side, as X approaches positive infinity, which is right, my Y, or my f of X, is approaching, well, since I'm going up, that's also going to be positive infinity there. So this one got a negative infinity, though. I don't like that one. I want the one down there with positive infinity like that. So again, sorry, it's a little bit off screen. Those are not nearly as bad as they look once you get your directions down. And I think the matching questions on quizzes are very helpful for that. Last slide. You just ask even or odd, positive or negative, but nope, this time we don't have a picture. Out of this long function, the only one that matters is this one. Why is it this one that matters? That's my degree. It's degree 5, highest exponent. And 5 is an odd number, so it's odd. And that very same term is positive, so it's a positive and odd function. You can type it all in if you want to. Since it's positive, it'll go up on the right, and since it's odd, it'll go down on the left, because they got to go in opposite directions to be odd. So which one do we use on this last one? Which term do we use? Remember, we want the one with the degree, aka the highest exponent. So we want this one. The second power means it's an even degree function. But that coefficient on it is -9, which means it's going to be negative. I could graph that in Desmos. What I'm going to see is I'm going to have a graph that, since it's even, either both sides are going up or both sides are going down. Since it's negative, I know it's going down on the right side. Since it's even, it has to be going down on the left side. Now, I don't know what happens in the middle. I just know about the end behavior, which again was the key topic here. So thank you for making it through my rush video. Hope that helps. Make sure you have the note sheet. Look over that a few times. Have a good day.